Hi, folks. Happy holidays, and thanks for joining me for this session with the Festive Tech Calendar 2023, where I'm going to introduce you to cloud-native deployments on Azure with GitOps and Flux. My name is Josh Carlisle. I'm a Microsoft MVP and also a principal engineer and architect at Zscaler, where I focus on building cloud-native platforms. So without further ado, let's go ahead and dive in. So what's the agenda for today? Well, we're going to get started with an overview of what GitOps is and why you should care at all. We'll cover some details around Flux and how it works, and then we'll show how you can natively bring GitOps to Azure Kubernetes services, which I'll refer to as just AKS with Flux. So before we go and talk about GitOps, let's review briefly some of the traditional deployments that we do today. If we're automating our deployments, like you should be in the cloud-native world, we're generally working on a platform like GitHub or Azure DevOps, or maybe even Jenkins. On those platforms, we're building some sort of definition with our deployment pipeline, which usually lives or is associated with a code repository. That pipeline is really our desired state, the source of truth for our deployments. We then have some sort of trigger event, which could be based on a code change, change of the pipeline, or even it could be a manual trigger event. This then executes our pipelines, which then push the changes to our deployment targets. The key here is that this is a push. So what does GitOps do differently? Well, we still have our manifest. This is typically some sort of IAC or infrastructure as code file, or in the case of Kubernetes, some sort of deployment manifest. Now, those manifests live in a Git repository, and changes to those manifests are done through a pull request. Now, that pull request can be reviewed or go through approvals or any kind of other workflow that your organization has. Now, notice right away, though, that we're treating these deployment files just like we treat our code base. Now, this is generally a good thing and should be immediately familiar to most of your developers. Now, as opposed to a push model that only occurs a single time, in GitOps, we have a pull and synchronization model. Now, this is usually accomplished by some sort of GitOps operator, which will continually look for changes in the desired state. And if changes are detected, then those changes are then applied to the deployment environment. Now, in this case, it's our AKS cluster. Now, it, however, does not really stop here. The operator then continuously reconciles the environment against that definition. So if drift occurs, like something like a change made outside the proper deployment pipeline, then the GitOps operator ensures that the environment is returned back to the desired state. Now, identifying and mitigating drift is a super important and powerful tool for modern cloud-native applications that are typically very complex and hard to manage from an operational standpoint. So now that we have a bit of a foundation with GitOps, how does Flux actually work? Well, Flux is a set of operators and custom resource definitions that are deployed to your Kubernetes environment. Flux needs to know some of the location of your repositories and other details about your type of deployment. These definitions are done through the CRDs that we deployed. Now, Flux's source controller uses these source definitions to then reconcile with the source's repository. Now, Flux understands various types of deployment manifests, from traditional Kubernetes manifests to customized to Helm, and even Terraform. Now, there is a specific controller for each type that know how to work with that specific deployment type, and they handle all the details of the deployment and the reconciliation. Now, these controllers will also identify any kind of drift or changes that occur and continue to ensure that your environment matches your source of truth. So at this point in time, you may be thinking, where does Azure fit into the picture? Well, Azure, and specifically AKS, has some native integration with Flux. They actually have implemented a set of extensions for Flux that make working with Flux very familiar to anyone who is familiar with Azure tooling today. So we can use tools like Azure CLI, PowerShell, or Bicep to actually configure Flux on AKS. Now, there are some differences with Flux and AKS. Instead of defining our own sources through custom resource definitions, we'll instead define them through ARM. Now, Flux and AKS has an additional controller. These are the Flux config controllers you see here in the diagram that actually work with the AKS data plane configuration for sources, and will create sources required by the Flux controller on your behalf. Now, this allows us to use all of the familiar Azure tooling, deployment methods, and the portal even with Flux on Azure, via this custom extension. Now, let's go ahead and see some of this in action. Now, we could define all of this through the Azure portal. That would be pretty easy, and I'll show you a little bit about that. But let's instead build something a bit more reusable and use Bicep to deploy Flux on AKS. So before we can actually get started showing how to work with Flux, we need an environment. We need an AKS environment. So I've gone ahead and spun up a new environment. Now, it's worth mentioning that if you want to have a similar environment, you can take a look at the bicep folder over here, and you can see that I have a shell script here that essentially executes the AKS main bicep file. Now, what's worth mentioning about this AKS main is that it's important to note this is not a production-ready deployment. The intent of this particular deployment is to try to get to the most inexpensive and cost-effective way of having an AKS cluster to be able to kick the tires with Flux. So that means we're using a very small VMs and very small nodes. We're using a basic load balancer. So this is definitely should not be used for production, but is definitely worthwhile if you're looking for a very inexpensive way to just spin up an environment for a little bit, kick the tires, and then shut it down for a very low cost. Also, if you want to follow along with this demo, I do have a repo available that has all of the Flux repositories defined and all of the bicep files. So it should be fairly straightforward to get up and running pretty quickly in your own environment if you want to follow along. So before we dive into the actual bicep files and the actual deployment of Flux, let's talk a little bit about the Flux repo structure itself. Now, I have defined some subfolders in my Flux folder called apps, infrastructure, and tenants. So that's the way I've chosen to organize a little bit my repo. Now, you'll see this is pretty common. Tenants not all the time because this is actually a multi-tenant demo, but in general, you'll see apps and infrastructure defined separately. Now, this is just a convention. This is not a requirement. There actually is a great article by the Flux team in documentation of ways of structuring repositories, considerations of whether you want a single repo or a multi-repo, what kind of structure you want in that repo, how to work a little bit with customized overlays, which I'll talk about here in a moment. But definitely take a look at this article, and this will start to give you some more insights on maybe what might make sense for your environment. Now, if we look at this folder here, you'll see that there is a common theme here. We have a base folder. Now, it's very common to identify common configuration that is regardless of the environment, it's the same configuration. So for most production environments, you're not going to be doing everything in production, right? You usually have a non-prod environments, things like dev and staging and QA and other types of environments. Now, there's a lot of commonality between all those environments, and we don't want to have to define all of those environments the same way every single time and have a lot of that burden of configuration. So instead of doing that, we define a base. Now we can have multiple deployments of Flux, and that Flux can be deployed to and pointed to dev or prod or whatever it may be, but they can still inherit from the base. And that allows us to simply define what the deltas are between environments as opposed to having to redefine the entire environment for each. This also makes it very quick and convenient to make broad changes across all environments if they're common changes as well. The other thing that you'll notice is that we have environment names in here. Now we have dev and under infrastructure I have dev and prod. Once again, this is a convention I've chosen to use. It's not a requirement to use it. You could have used development. You can have as many environments as you'd like to. But generally speaking, you can define different environments. And as mentioned before, you can point different Flux installs to the same repo, but point it to different environments. And you'll see that here momentarily when we start to get into the bicep file and that configuration. So let's quickly go ahead and look at what we have to work with before we do our Flux configuration. So I've gone ahead and deployed the Flux Festive Demo AKS environment, and it's just what you would expect from the AKS environment here on the portal. What you may not have noticed before, though, is that we have a GitOps option over here on the left-hand navigation. Now, we're not actually going to configure this through the portal. As mentioned earlier, we want to do this in a reproducible way. But if you did want to be able to create this for the portal, you can go ahead and hit the create and walk through the wizard. And pretty much all the settings that you'll see here shortly in our ARM template, you'll be able to apply into the UI and have pretty much similar results. So with all that in mind, let's go ahead and take a look at the bicep file that I keep referring to. So you'll notice that I have a deploy flux shell script here. And that shell script passes all of the appropriate parameters to an AZ deployment. This is your typical bicep deployment. I'm actually not going to scroll over to the right because it has a little bit of a secret in there. But as you'll see here in a moment, one of our parameters is a secret to my GitHub repo. And so you will need to pass in, as part of your bicep parameter, a secret that will then be actually stored as a secret in Kubernetes behind the scenes when it gets deployed. And those are the actual credentials that are going to be used by the Flux extension and by Flux to communicate with the repository. So I generally have a little bit of a breakdown in my bicep files. I like to organize things a little bit. So I actually have a main file, and the main file does make assumptions. So if you went ahead and deployed AKS by yourself without using my script, you may need to do some tweaking to the resource group reference. So just make sure that you are pointing to your resource group. You have nothing to do if you just followed along with this demo. And then I'm going to pass in some parameters. We have some resource prefixing to just kind of have some unique names. We have our GitHub URL that we're passing in. And then we have our token and our username. So these are all the parameters that our core bicep file, when we deploy Flux, is going to use. So let's go ahead and look at that file. So the first thing that we're going to look at here is, of course, we have some of the parameters that are expecting to go ahead and be passed in. I have some conventions that I'm expecting with the cluster name and so on and so forth. So once again, if you kind of deviate from the given scripts, you may need to do a little bit of a tweaking. So we get a reference to our cluster name. And the first thing we want to do is make sure that we have our Flux extension, right? So we're going to go ahead and add the Flux extension to our Kubernetes environment. And then this is where things start to get a little bit interesting. So this is the Flux configuration resource type that I mentioned earlier in some of the high-level architecture around Flux. So this it allows this is what the resource type that ARM uses for the deployment. And of course, we want to put it depends on the Flux extension. We can't deploy a Flux config without having the Flux extension in place. And then this is where we're going to pass in some of our options. Now, as you might see here that this is GitOps. The source kind is Git repository. You might think to yourself, well, what else would it be? Well, technically speaking, even though this is GitOps and we are using Flux, which is a GitOps platform, you can actually use other different types of repos. You can use a bucket if you'd like to use a bucket. There's more details available on the Flux documentation, but most organizations will use an actual Git repo because you want to be able to do some of the tooling around that you get around Git repos. Pull requests, approvals, reviews, run automated pipelines, maybe doing analysis on the deployment before it gets approved. All those kind of things that you get with tooling alongside common Git-based platforms. So for most part, the source kind is Git repository. Namespace is defined as Flux system. You should keep it as Flux system. There's some assumptions about that in there, and then we want to pass in our Git repo. And then there are some settings of how often we want to synchronize, right, with that Git repo. Sometimes you want to have multiple sources, and those sources may be defined, may change more frequently and change less frequently, right? So there is some tweaking that you can do to Flux to tell it how often do you want to attempt to reconcile and look for changes. And that's actually a best practice once you get into production. If you start getting into lots of workloads being managed through Flux, that you want to do some optimization to make sure that you're not putting too much of a heavy reconciliation burden on the AKS cluster when you don't need to for infrequently change things. The configuration protection settings is our username and password. Make sure that you encode this in base 64. At the end of the day, the Kubernetes secrets are in base 64, and I lost a good 2 hours to missing the base 64 encoding. for this particular setting. So ensure that you do that if you miss it. Now, this is where things get a little bit interesting. Now, these are the customizations. So I didn't really talk too much about Kustomize. Kustomize is a templating tool set for Kubernetes, and we define a lot of the elements that you saw a moment ago within our Flux folder as customizations. Kustomize gives us a great deal of flexibility for achieving some of the inheritance that and some of the base configurations that we were talking about, and other features that become really, really kind of invaluable. So we define these customizations. I have an infra and an apps and a tenants, and that should look pretty familiar to my folder structure over here. So what we define in here is going to be very much associated with the particulars of your environment. And then we can go ahead and say, okay, for this customization here, this is the actual folder in the GitHub repo that we look at. So this particular definition of this particular source is going to be looking in this infrastructure folder for dev. So right away, we can see that this deployment target, right, is going to be for dev. This is going to be for the dev environment. If I was defining this for my production environment, I would have a prod folder in there, or whatever I choose to name it. This is also when I can start to fine-tune some of the synchronization intervals and retry intervals for Flux to tell it how often it should try to reconcile. Now, I've gone through and listed out each one of these. Now, as you notice here, we have a depends on. So we can see right away that tenants depends on apps, and then we can see that apps depends on infra. So this is how we can ensure that things are deployed in the right order, and it requires a successful deployment of that dependency before the subsequent deployment is made. So pretty straightforward to get started with a bicep definition. You just need to make sure, obviously, that you have, before you deploy the bicep definition, that you have all of this folder structure in place and available in your Git repo before you do your Flux deployment. So let's go ahead and bring this all together and go ahead and deploy our Flux configuration. So we're going to go ahead and clear this out. And we are in the bicep folder, and we want to do a deploy Flux. And let's go ahead and see this in action. So we've jumped forward in time about 15 or 20 minutes. Do be patient a little bit with this. It can take a little while to deploy and come back as complete. But as we can see here, our script has run. It's given us some what looks like positive results. But let's go ahead and look at this in the portal and see what we have. So if we go up to our Flux Festive Demo AKS, we should now have a populated GitOps section, which we do, and that's good. We're seeing all green check marks, so we don't have any reconciliation issues. There was no problems during the deployment. But let's go ahead and look at some of the details here. So we have some overall state information and some of the deployment characteristics of our deploy and our namespace. But let's see what actually got deployed. So great. So what we can see here is these are the actual items that got deployed via GitOps. As you can see, if you remember from earlier, you saw pod info, but we also have some various Nginx and Redis deployments that we also had that fell underneath our infrastructure. We can see here where things were applied. This was an infrastructure piece, this was an apps piece, and then we can, of course, look at our source. This is the source that we defined, and the branch, for example, and here's our repo that you can use if you'd like as well. Or I would probably rather say fork it so that you can make modifications to it. And then you can actually see our individual customizations. So our infrastructure, our apps, our tenants, and we can see the sync intervals and the path inside the repo. So With a fairly small bicep script, we were able to get all of our configuration down. Now let's just see if an actual deployment in Lens. So let's go ahead and open up Lens here. For those of you not familiar with Lens, this is actually OpenLens, which is an open source version of the commercial Lens that allows us to kind of explore a Kubernetes cluster. So if we open up this now, and we can see we have various namespaces. If you recall, we had a little bit of my multi-tenant, so we're seeing Contoso and Aviato namespaces, although there's nothing in there. But we do have our Nginx and Redis deploys. So with just a few minutes of work, we were able to get up and running with GitOps using the Flux extensions for AKS. So what's next? Well, my suggestion is to go ahead and check out some more information on the Architecture Center, the Azure Architecture Center, on GitOps for Azure Kubernetes Services, and you can learn a little bit more about the architecture itself. There are also some additional tutorials that you can do to dive a little bit deeper into various configuration options for using Flux. And then lastly, definitely explore more of the Flux documentation. They have a lot of great guides and different use cases, and you can explore a little bit more about what some of the different controller options are. Maybe even diving a little bit into using Terraform to deploy some of your resources as well. And with that, I hope you enjoyed the session and you feel ready to jump into learning more about Flux and Flux on AKS. Happy holidays and take care.